Hi everybody, this is Dr. Bricker here with some information about this lab activity for week 12. It's the Snell's Law lab activity. So what you see here is the landing spot for the Blackboard course. So if I go to Learning Materials, you've all seen this, week 12. And I don't want to open up the notes, so I'm just going to do this. If you notice down here, there's a refraction lab activity. That's the lab for this week. So I'm going to click this, and here's a lab activity. It's the document here. So you could either work alone, or if you still have your group members' email, you can do this as a group. There's no formal write-up for this activity. It's just go through, do the calculations, answer any questions that you might be in the activity, and then submit it. So when you finish it, you can submit it this way. This is probably the easiest way. So if you have an electronic copy, which you should, save it somewhere on your computer, and then you can just upload it here. If you can't figure that out and you want to email it to me, that would be fine too. It's just for me to keep track of everything, it's easier if you actually just upload it here. Okay, and it's not actually due until Tuesday the 14th, so plenty of time to work on this. So here's where it is, Snell's Law activity. So this goes along with the optics chapter. So if I click this, I'm going to open it up and view. I'll just do edit document so I can go through this. So this is what you'll be submitting to me, this actual activity. So there's some calculations, things like that. Now if you want to print it out and write it down instead of trying to type everything out, you can do that too. You'll just have to figure out a way to get it to me. So some people use their camera, just take a picture of the individual pages. I think Apple has something called Note that'll make them look really nice. Anyway, I'll leave that up to you, however you want to get this to me. Either just type it out, answer the questions by typing, or if you want to print it out and handwrite the answers too, that's fine. You just have to, again, figure out a way to get it to me. So the activity starts here. It's one of these PHYS. So if I hover over this, control click, I just hit the screen, control click, or you can just copy that and put it into your browser. It's going to look like this. I can just click here, and then the PHYS should open up. And we're going to be using this one called Intro. So here's a laser. Light's coming out of the laser. This is in air, so the index of refraction of air is 1. This is water. So part of the ray is being reflected. This is the angle of incidence. This is the reflected angle. You know that those are equal to each other. This is where the refraction is taking place. This is where light is actually bending. I can grab the protractor, move it up here, carefully put it here, and the incident angle is measured, remember, from the normal, so from here over to here, 30, 40, maybe 46 degrees. That's this angle. The refracted angle is measured this way. So it looks like 10, 20, 10, 20, 25. Can't really tell if that's 30 or not. 20, 25. Yeah, I guess that's 30 here. So the incident angle would be about 46. The refracted angle is about 30. So from Snell's law, you can, verify that. So the lab consists of, putting this at different angles, measuring the incident and refracted angle. There's a few mystery materials that we can figure out what they are. So for example, let me do mystery A. So we don't know what mystery A is. We're trying to figure out the index. Oh, sorry, that's class. Mystery A. Okay, so here's the incident angle. Here's the refracted angle. So based on this incident angle, this refracted angle, you can figure out what the index of refraction is of this material, and then you know what it is. It's sort of a fingerprint of this. Okay, so that's using Snell's law. There's something called total internal reflection, and it only happens when you go from a higher index of refraction to a lower index of refraction. So let me make this glass, and let me make this one air. So if you notice, if I take this and move it around, whoops. Okay, so you can see here's the laser. This is a higher index, this is a lower index, so light is being bent away from the normal. Now if I slide this direction, it's getting this angle of refraction is getting larger and larger as I go this way. And you get to the point where none of the light leaves the glass and enters the air. So I'm slowly going this way. So that's the critical angle. None of it's being refracted. It's all being reflected. Again, this is the basis of fiber optic cable. We're leaving all of the light inside the glass here. So if I go this way, I'm still getting some refraction. When you get to the point where you don't have any, right about there, that's the critical angle. So the refracted angle is 90 degrees. This is the critical angle then. So you can solve for the critical angle. Now it only happens when you go from a higher index of refraction to a lower index of refraction. So be careful. One of the questions asks you to calculate the critical angle, and it's a situation where you're going from lower to higher. You can't have it there. So in a way, maybe it's a trick question, but just be careful. You'll get one situation when you go through the lab that's not actually physically possible. Okay, so go through that activity, answer the questions, and then upload it to me. If that's not working for you, just email it to me. I would prefer you to upload it, but if that doesn't work, just email it to me. And again, you can work on this one on your own, or if you're still in contact with your lab partners, you can work with them. If you have any questions, let me know. Talk to you soon. Bye-bye.